Okay, there are no data here. Right, see here, no, the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But the final two hours, there are no contour. But it shouldn't be this way. So we want to know what happened here. So we just print this data to see if we have a data here. So let's do this one. So let's try if we can find the reason for this one. 0. Oh, Jesus. Yeah, oh, 0, 0. How is that possible? 0. Yes, you are right. Yes. Yes, you are right. And that's are you able to plot the data? Do you? You can? Okay, then so there must be a data corruption for myself. Okay, so okay, excellent. So you are able to do it, and please give me. Okay. Please wait for me. I will try to. Okay, wait for me, and I will get the data here again. If you are able to do it, then that means there's a problem in my data. try to make a copy of the data here. So right. Okay. Okay, I have updated the data, so let's see. All right, yeah. So that is the data I use. There's a corruption on my data. So you see here, I have uploaded the data. Then the minimum value and the maximum value is correct. So yes, so yes. That is because of the corruption. Because my USB, the disk space is full, so it was unable to make a completely copy. Yeah. Yes. Thank you. Excellent. Okay, so now let's have we can run the code again to produce. So we to close this one. Then we can completely rerun the code. Yes, good. Right. So now we should be able to get all of the figure here. No, not this one. Yeah. You see here, right? So now I'm able to, you see here, I have 12 hours of output data, which can be clearly see here, and which is quite good. So, and let's have a look at this one. Yeah. So this is the first hour, and you can see the wind here, and 12, 13, 14. Right, so we have 12 hours of data for you. And I will be able to give you more data for you to do for your final presentation. No, not final report. You give me your final report next week this time, and you can put your data in a PPT or animation with music. They are all okay for you. Okay, you can decide it. So let's first let you enter your grade here for this exercise if you have done it. Then I will give you some suggestions for you to complete this work. And let me, okay, this is for, so this is the last time for you to enter your in-class grade. So let's see, 2026, 0603. Right, okay, please raise your hand if you have done it. Then let me check it, and you come forward and to enter your grade point, 5 point. Yes, okay, 5 point, please. Okay, yes, please. 5 point, please. Anyone else? Yes, 5 point, please. Okay, okay. Okay, very good. 5 point, please. Anyone else? Okay, very good. 5 point, please. Very good. 5 point, please. Yes, 5 point, please. Yes, 5 point, please. For you. Anyone else? Beautiful. 5 point. 5 point. Okay, please. This will be the last time for you to enter your in-class grade point.
data 什么那些东西，那个版本都必须得往下降才跑得动。
对。
那接下来老师给我们的档案是也得用同样的，就是用同样的那个版本是一样跑得动。必须可以跑得动。
Yes.
所以如果这个版本设定好了，这个环境设定好了，等等的档案也是可以分析的。
Yes.
好。
Yes. Good.
然后上周或者是那个今天不是前阵子还没有弄成功，那个环境一直要调。
Yes.
环境要调，版本也要一直往下降。
Yeah. That is the beauty of using the Python. You have to experiment, do some experiment.
到底是什么样的档案？回到2G、20G，因为我看它跑出来的结果也才。
We have a.
它那个档案里面到底是？我上周想问。
For 12 hours, right? For 12 hours is about 2G, and if for 24 hours, it will be about 4G. So if for 72 hours, yeah. So it's about 12G. So I think I will give you 12G of data for you to do an animation, to make a movie. So that's all up to you. And later I will. It is not a single file, several files. Okay. Anyone else? Okay. Now, let me give you some suggestions for your final report to be delivered last time. And let me check this one. If I say. So for your final report, everyone will be different. So your grades will depend on how much effort and the science you have poured into your final report. So let's have a look at here. right? Okay. This is a very beautiful. We have used a model to produce a Typhoon. So my suggestion for you is the first, of course, I will send you a link for 72 hours of the model predictions for 3 days. So, and the total size of the disk space you need maybe 12 gigabytes. So there will be, so this is one, so you will have a 6 NC file times 2 gigabytes per file. So it is about 12 gigabytes. You can determine what you want to do with this, but this is very good. And animations between the 1st to 3rd of June 2026 for Typhoon Jangmi. Yeah, okay, this one is very beautiful. Typhoon, for Typhoon Jangmi. From Wolf. Okay, run by myself, run by my lab. Okay, run by myself. It's not download from other location, run by Kuo-Ying. Okay, right. I have used my computer to do this. So my suggestion for you is, so I give you the permission to use this data. You have my permission, okay? The data, the copyright is from me, not from others. So don't worry, you can use any. For your final report, then my suggestion for you is that, you see there's a Typhoon here, right? You have learned weather, you have also learned lots of dynamic meteorology or the atmospheric thermodynamics, physics. So I would suggest you to make a cross-section here, across Typhoon. You can do this, because I have done this, and I don't want to show you. I want to let you do this. I want to let you have the fun. I don't want to keep all the fun. I want to let you do this. So this is for your final report next week. Is that clear? So one suggestion for you is to make a cross-section. You can ask the AI to help you. Okay. You can ask it, and to make a cross-section, then you will be able to see, in that case, you will be able to see the vertical structure of the Typhoon. It is very beautiful and quite amazing. You learn about the dynamics of Typhoon, the Typhoon formation, and you want to learn the circulation associated with the Typhoon. You see here, this is the center of the Typhoon, and on this side it is northerly, on this side is southerly. So you know that the Typhoon, there's a secondary circulations in the vertical directions associated with the Typhoon. But normally you read the description about the Typhoon from the textbook, from the work done by others, but now you have the data. You have the data, so you can do this work by yourself. Okay, so that is very good. So my suggestion for you is, you can, of course, that's one suggestion. You can also do other calculations as well for you if you like. With this data, it is very convenient for you to do this beautiful analysis for the Typhoon. So I think maybe I can show you some of the results I have produced by myself. And please do it by yourself, because this is for your final result, for your final report, okay? So see here, right? It's quite amazing. It is quite beautiful. I love this one. So you can find a cross section for this Typhoon. You can do it from the surface there all the way to the top of the models. and which will be able to enable you to have a better understanding of the typhoon, and also the circulations associated with this typhoon. If, as we said, that if the model is able to produce this one, then it must be, there are processes which have been included in the code, so that you can see the result. So let's come back to here again. If we come back here, so please. So this equation. Okay, then let's have a look at this, the model equations. The one we use for this one is called WRF, the most advanced models. And after this semester, in the future, if you like to continue this research, then it is very natural for you. Because in this semester, you have already learned how to do the numerical integrations. So you will be able to learn how to run the models. And okay, so we can see that the governing equations you see here is, these are the advanced numerical weather prediction courses. So when you enter the graduate schools or you do your PhD, then you will do this. This is the horizontal momentum equation, and in this case, it uses the eta, which is the terrain following coordinates, and this is the vertical momentum equation. So the first one and the second one, these describe the conservation of the momentum. Okay, this describes the conservation of the momentum, and for the vertical part, which you can see clearly the gravitational force is here. So this part, the contribution from here is very big from this. This is a horizontal flux turn, the horizontal convergence of divergence of the wind, and but this one is for the vertical part. Which one is, this one is quite significant to resolve this turn. And then let's have a look at the thermodynamic equation. So this is the energy for the energy conservation. This is for the momentum conservation, and this one is for the energy conservations. Here you see there is a diabatic turn here. The diabatic turn is here. So when a typhoon forms, the energy is from the condensation of the water vapor. When water vapor condenses, it releases the energy, so it increases the temperature and reduce the density of the parcels. So it produces vertical motions. So as you can see here, so this is the energy source. This is very important for the source of energy. What I want to say here is that you can see a typhoon is able to produce by a model, which means the dynamic and the thermodynamic and also the energy conversion must be working well. Otherwise, it is impossible to produce this equation. And these are the moisture and scalar advection equations, the conservation of the mass. If there are no condensation and evaporation process, okay? So when we run a model to solve this one, we will try to find to calculate the models for this one. And if you are interested, you can do this one by yourself during the summer holiday. You can do this because this is a wolf model, and it is an open source model. Everyone can download it. You can do it. But be aware that you need a quite significant resource of computers to produce this one. I use the 6 server to do this calculation simultaneously for these calculations to produce. So this is the wolf model, and please have a look. And it's good for you. So here, let's have a look at this result. So the data you have for you is from the wolf modeling systems with advanced weather research and forecast. So the first W means weather research and the forecast. And to do this forecast, which is very similar to when you do the numerical integration of the ordinary differential equation, this is an initial value problem. So we need to have the data. We need to have the data to do the integration. So see here, right? We have the graded data from the global forecast systems to be able to initialize the model. So here you see for each wind bar, they are at a particular grid point. So when we do the calculation at each grid point, then we combine the result. We solve the primitive equation at each grid point. Then when the result combined together, that is what you see here. Okay, when you see the result, it is a combination of the grid point. So this is the initial value problem. We need the external data resource, such as the observational data. And in this case, the observational data are from the radio sounds, satellite data, airplanes report, or the ships. And the conventional observational data, such as the radio sound, service wind stations, and the alternative observational data also include the radar. So radar is very good, which can provide additional data. So if you have a look at here, in this case, Typhoon is located at about 800 kilometers northeast of Taiwan. Here, this is an oceanic area, and we do not have the observational data. Observational data, especially for the conventional observational data, they are only available from the land area where people live. You can have the data available. But for typhoon such as this one, and the typhoon occurred over the oceanic area, we do not have the data. So we need to use the satellite data or the remote sensing data, radar and the airplane, for example. Then to do the integration, we need to have the terrestrial data, which means the surface terrain. So here you see that the pressure is low, which means it is over the mountain area. So over the mountain, and then you have to have the terrain structure so that you can calculate the surface albedo and also the boundary, atmospheric boundary layer, and the heat transfer, and the moisture and the water during at the surface. So this is very complicated, my dear student. It is a big one. So as you can see, the entire wolf model, it is about 30,000 lines of the fortune code. This is entirely fortune, not from Python. It is fortune. so you can run parallel, in parallel. And this is, yeah, right, okay, it's a wonderful, amazing, and we need to have data. Then this is the preparation for the models. Okay, so here you see the WRF pre-processing system, which means that you have to prepare the data so that it can be used and to input to the models and then to run the weather prediction. So these are we call pre-processing, and this is the data, and for what you see here, real here means the real data. So I can show you how we get this data for your information. So if I come back to here, okay. Maybe I will show later. Okay. Right. Okay. Right. Okay. So then, after we conduct we run the models, then we will output the models. As you can see here, there are several packages you can use. So this is entirely, or you use Grace. And Fortune, most of the code are Fortune based. But now with the Python, we can do the analysis very quickly. Okay, so this is the WRF model systems, which is very useful. And here you see that we have the forcing terms, and these are very important. And you can see the forcing term. This is the Coriolis force is from the Earth's rotational effect, and the mixing, and also the diabatic process to this one. So these are entirely very important. So there must be a source. What I want to say is there is an energy source for Typhoon. There must be an energy for this one to organize. It organizes by itself. And the energy is from the diabatic process. This one, so the energy goes into the equation, it changes the density. When the temperature and the density change, it changes pressure gradient force. Pressure distribution change, it changes the wind. The pressure gradient, it has a reflect. So the entire process is very complicated, and but with the computer we can solve it. You see here, the diabatic process, this is a diabatic because you have a condensation of the water vapor, and then it changes the temperature, it changes the pressure. Then when the pressure changes, you see here the change pressure, you have zonal gradient and also the meridional gradient, then you change the wind speed. The wind speed change, it reorganizes itself. This is very beautiful. And this is how we are able to solve this, to make numerical weather prediction. It's because of this process, and then we are able to do it. Today, even for this kind of prediction is still ongoing. This is not the end, but dear student, not yet. We are still very far away from a very good prediction of typhoon. It's still very complicated, and to predict the strength, the typhoon track is still a big challenge, even now. Okay, let's take a 10 minutes break, and then we will come back. Let's take a 10 minutes break.